Welcome to School of Chemistry. Today we'll be looking at the alkane series. The alkenes are a homologous series of unsaturated hydrocarbons, which follows the regular molecular formula CnH2n, where n is greater or equals to 2. They are unsaturated compounds containing a carbon-carbon double bond. Examples and names of members of this series includes, let's look at the structure. We have ethene, C double bond H2, that is C2H4, that is ethene. Remember, the tetravalency of carbon is always maintained. We also have propene, C3H6, that is the structural formula up there. We have but 1-ene, because the double bond is on carbon number 1, that is why it's but 1-ene. It's an example of an alkane. We also have but 2-ene, where the carbon double bond is on carbon number 2. We also have pent-1-ene, though the structure is not here. So these are names of common names of alkenes, formula and structure. Let's look at the first member, ethene. Ethene is the most common of the alkenes. It's the first member with the formula C2H4, and is far the most important member of the alkane series. Ethene is one of the products obtained from the cracking of petroleum. We have the equation. When you crack petroleum like C17H30, that is a heptadecane, you get ethene as one of the products of the cracking of that large compound. Laboratory preparation. Ethene is prepared by heating ethanol with excess concentrated tetraoxosulfuric acid at 170 degrees Celsius. It takes place in 2 stages. 1, on mixing ethanol and the acid, the ester ethyl hydrogen tetraoxosulfuric is formed. Then the ethyl hydrogen tetraoxosulfuric on heating will now produce ethene and tetraoxosulfuric acid. It's actually a dehydration reaction. Physical properties. It is a colorless gas with a sweetish smell. It is sparingly soluble in water. It is slightly dense than air. It has no action on litmus. Chemical properties. Combustion. Ethene burns readily in air or oxygen with a smoky and luminous flame because of its high proportion by mass of carbon. In the process, it oxidizes completely to form water and carbon 4 oxide as shown in the equation. Ethene forms explosive mixture when mixed with air or oxygen. Addition reactions. Ethene undergoes addition reactions with hydrogen, halogens, hydrogen halides, etc. An addition reaction involves the direct addition of a cracking reagent across the double or triple bond of an unsaturated hydrocarbon to yield a saturated compound, as shown in this equation, or at least one in which the degree of saturation is increased. For instance, we have ethene reacting with XY as the attacking reagent to form the new compound where the double bond of the ethene has disappeared and the tetravalency of carbon is maintained, or the carbon atom is saturated, because the attacking reagent has added across the double bonds and the unsaturation or the degree of saturation has highly increased. The compound is actually saturated. So in addition reaction involves the direct addition of an attacking reagent across the double bond or triple bond of an unsaturated compound to yield a saturated product. Let's look at hydrogenation. That is the addition of hydrogen. If a mixture of hydrogen and ethane is passed over finely divided nickel, ethane is formed as an addition compound. You can see the reaction there. The double bond of the hydrogen is gone and we have ethane as the new compound. Reactions with halogens. Chlorine reacts with ethane at room temperature to form 1,2-dichloroethane, saturating the double bonds of the ethane to form dichloroethane, which is a saturated compound. So addition reaction generally use saturated compounds. Polymerization. Polymerization is a process whereby two or more simple molecules are linked to form a much larger molecule. For instance, ethene and its derivative undergo polymerization to form polyethene, as shown in the equation. If it's your first time on this channel, please do not forget to subscribe, like, and comment.